Good morning, class. As you've noticed by now, I'm out sick today, so I've asked Mr. Stenkel to show you this video so that you can work on the pH worksheet today. These equations I have written here are the ones that you'll be given on tests and quizzes, and you're going to need them for class today. So go ahead and take some moment here and write them down. The first one we've already used on our last worksheet, and it'll come up again in this worksheet. The other three you should have seen in the pH video. And I've written both forms of the pH and pOH equations. Since some of you haven't worked with logs yet, you'll get both versions. So if you're solving for pH or pOH, use the ones on the left. And if you're solving for the concentration of hydronium or hydroxide, you use the version on the right, and that's already rearranged for you. So go ahead and copy those down now. Now make sure you have your pH worksheet out. We're going to work through a couple problems from that, and then you'll spend the rest of class working together on the rest of the problems. At the end of class, turn your worksheets with your names on it into Mr. Stengel for when I get back. So look at these problems. For all of the problems, it says for each of the following problems, answer the question and then determine whether each solution is an acid or base and give your reasoning. For determining whether it's an acid or base, you have to recall that a pH less than 7 or a pOH greater than 7 is an acid. A pH greater than 7 or a pOH less than 7 is a base. We'll look at the first problem. This one wants us to calculate pH based on the hydronium ion concentration. So this is where we're going to use pH equals the negative log of the hydronium ion concentration. Equals negative log of 8.5 times 10 to the negative 6 molar. So now we plug that into a calculator. And the one I have here works similarly to most of your calculators. So we take negative sign, which yours might be a plus minus key. Then we do log, L-O-G. We put in our number, which was 8.5 times 10 to the negative 6. And we close the parenthesis. Push equal, and we get 5.07. Now for these problems, don't worry too much about the significant figures. For pH at this point, just give me 2 decimal places. I'm not going to be too picky about significant figures for pH because there are special rules that we're just not going to worry about at this point in time in the year. So we're going to say the pH equals 5.07. Then we look, is that an acid or a base? Since it's pH we calculated, and it's less than 7, that makes it an acid, because the pH is less than 7. The next problem, we're looking for the hydroxide concentration. And so we are using the opposite, the inverse of this equation, and with OH instead of H or H3O+. So we have OH minus equals 10 to the negative pOH. They give us the pOH, so we say 10 to the negative 3.42 will be our hydroxide ion concentration. So we go to plug that in the calculator. You can either use the inverse log function, which would be second in the log button on your calculator, or you can do 10 to a power. So I can say 10 to the power of negative, look what our number was here, 3.42. Close the parentheses and get our answer. We get 3.80 times 10 to the negative 4th. And our units would be molarity, so big M, OH minus. And if we look at the POH that they gave us, the POH is less than 7. POH less than 7 means I have a base. It's a basic solution. Number 3 looks at the equation with pH and POH. And we said at room temperature, pH added to POH is always going to give us 14. So POH must equal 14 minus 7.4. So we find our answer is going to be 6.6. And that's our POH. pH and POH do not have units. Since the pH is greater than 7 and the POH is less than 7, it is a basic solution. So there's an example of how to use each of the 3 new equations. Like I said, pH and POH equations work the same way, it's just different numbers and values you're putting in. So from here you should be able to do the rest of this worksheet. Some of them will integrate several of the equations together, and you could be asked at some point to use our original equation that we used on the last worksheet here to calculate H3O plus or OH minus first and then solve one of the others, but you can get around that as well. So this is how the hydronium ion concentration and the hydroxide ion concentration interrelate to each other and how we solve problems. For the remainder of class, work through these problems, work together, look in your book if you have any further questions, and help each other. And when you're finished with the worksheet, turn in your worksheet. After that, spend the rest of the class time starting to review for the final exam.